Welcome to my project. For my project, I wanted to focus on pro-tan color blindness. When I was growing up, one of my good friends was pro-tan colorblind. The purpose of this project is to display the world how he would see it. The project uses a camera to take the real-world RGB color and turn it to a pro-tan color profile and displays it on an LED ring. The purpose of the device is to debunk many of the misconceptions that people have when it comes to someone that is colorblind. Many people assume that color blindness just means that they see something as black and white, or that the colors are just specifically a different color. But that's not true. When it comes to pro-tan color blindness, it's really a range of color that they can only see the visible light. This device will help to educate people by giving them a real-world application and seeing the colors that someone that is colorblind would see in real time with the real-world colors. Shown here is just the wiring and the hardware side of this device. It uses a camera and an LED ring that is wired into the Arduino with a couple of resistors. This is where this project starts to get a little funky. This camera is definitely not the most optimized piece of hardware ever. Thus, I had to find quite a few workarounds. One of those workarounds to get this working was to use an older IED of Arduino, shown here. What you're seeing now is a plugin that has been developed for this camera that it works specifically with the older IED. This was a problem as it did not run the new NeoPixel stick, so I had to do a workaround where I would save the image from this IED, load it into P5 as you'll see in a second, and then load it back into the newer IDE to run the NeoPixel LED stick. Currently on screen, you're seeing the photos that it took while I was testing. Now we'll hop into P5.js, and as you can see, I have a photo loaded up that was taken from the camera. Shown on screen now is the eyedropper tool that was coded into P5, working and collecting colors from the picture. Those colors are then sent back to the Arduino and being displayed on the left-hand side of the LED ring. Unfortunately, you'll see on the right that the colors on the right-hand side of the ring are not changing, and those are supposed to be the pro-tan colors. For the final presentation in class, those should be fixed. Lastly, shown in P5, we have the code that uploads the image, and then the code that runs the eyedropper tool, which is very simple, and then the simple code that sends the RGB values back to the Arduino. And for the Arduino side of things, we have this code shown here that is running the NeoPixel stick, as well as receiving the RGB values from P5, as well as the case and if statements written to modulate the pro-tan color spectrum.